All right, this is the Algebra 2 Unit 2 study guide, or the review video over the study guide. I'm going to work through the problems here on the study guide. These are problems that are modeled after what you will see on the test. So if you're able to do these problems, you'll be well prepared for what you're going to see on the test. So I'm just going to get right into it and start working out some of these problems. First group of problems are from the beginning of the unit. This is where we are combining simple x or y equations or inequalities. We're combining them into a single equation. So if you remember, the way you do these is first thing you have to do is set both equations or inequalities equal to 0. So I'm going to work each of these out and put them equal to 0. So like in this one, I'm going to subtract 3 from both sides of this equation so that the 3 cancels out and makes a 0. And 3x, 5 minus 3 is 2. So I end up with 3x plus 2 equals 0. And on the other side, I'm going to subtract 2 from both sides to cancel that 2 out. And so 4y minus 5 equals 0. So now that both equations are equal to 0, I can basically put them together. Because they both equal 0, then they must equal each other. I'm actually going to erase this and bring this up. So what we've done is we've combined the equations. And let me fix this. Sorry about that. And then I need to put it into what we call standard form. Remember, standard form is to put it in a form like this with x and y on one side and all the constants on the other. So we can really do this in one step. I think that's something you guys are all capable of at this point. We're going to subtract 4y and subtract negative 2. When I do that, the 2's cancel out and the 4y's cancel out over there, leaving me with 3x minus 4y equals negative 5 minus 2 is negative 7. And so that would be the final answer for that first one. I actually think I can just put this down here. Oops. Put that guy right there. There we go. All right. Now looking at this other one, same idea. Start off by moving things around. We're going to subtract 6 from both sides here. That gives me 2x minus 10 is less than 0. And then on the other side, I'm going to subtract 4 from both sides. That's going to give me a 0 as well. And it's going to be 3y plus 1 is greater than 0. So now we take a look at these and see that one of them is less than 0 and one of them is greater than 0. So the 2x minus 10 is less than 0. And the 3y plus 1 is greater than 0. So that means that 3y plus 1 is greater than 2x minus 10. So remember, it's all about whichever one is less than 0 goes below and the one that's greater than 0 goes above. Then I'm going to come through and I'm going to solve. I'm going to do the same thing I did over here. I'm going to move my constant term over. And I'm going to move my y term over as well. And when I'm done, these cancel, and I end up with 2x minus 3y is less than 11. And so that would be the final expression. So again, put them equal to 0, combine the equations, solve for standard form. And then they want us to be able to take a standard form equation and convert that into slope-intercept form. Slope-intercept form is right here. It's y equals mx plus b. You should know that, be super familiar with that. There are 2 steps to this. First step, move the x, and the second is divide the y. So just to kind of walk us through each one of these, move the x here means I'm going to subtract 4x from both sides. That's going to cancel, leaving me with negative 2y equals negative 4x plus 10. Then I'm going to divide both sides of the equation by negative 2, divide everything by negative 2 actually. Those are going to cancel, giving me y equals Negative 4 divided by negative 2, that's going to cancel those negatives out, giving me 2x plus, and then not actually plus because I have a positive and a negative here. So 10 divided by 2 is 5, and it's going to be negative because there was a negative 2. So that would be the answer for the first one there. Okay, next one, same process. Move the x, minus 3x, minus 3x. Those cancel, leaving me with 4y equals negative 3x plus 16. So then I divide everything by 4. Hopefully by now this is something that comes really easily for you because you've done this throughout your algebra career. Divide everything over there. We have a negative 3 divided by 4. That becomes a fraction, and 16 divided by 4 is 4. So there's our answer for that one. Okay. One little difference on the inequalities that you have to remember, and I put an example here that ends up doing this. But when I move my x, when I go to divide the negative 3, I have to remember that when that happens, I end up needing to do something about the fact that I divided by a negative. You remember when you divide by a negative, you have to switch the direction of the sign. So that sign becomes greater than. Obviously, the negative 3 cancels out, giving me y, and then greater than. And then I just work out the rest of it. I have 2 negatives here, so those are going to switch to positive 7 over 3x. And then 9 divided by negative 3 is negative 3. And so that's how you convert standard form to slope-intercept form. All right. And let's see what comes next. I believe the next thing here was solve absolute value equations. Again, more solving of equations. I have here x plus 5 inside absolute value equals 7. So remember, when this happens, you have to do 2 equations. You have to do the equation x plus 5 equals 7. And then you have to do the equation x plus 5 equals negative 7. And you solve both of those equations. We can do this all at once, though, because the steps are the same. We're going to subtract 5 from both sides of these equations. That's going to cancel. That's going to cancel, leaving me with x equals 2 and x equals negative 12. So notice I just did it all at once because I knew that the steps were going to be the same. And so your solution are each of those, 2 and negative 12. Looking at the next one, similar idea. I need to make this into 2 separate equations. 2x minus 3 equals 5, and 2x minus 3 equals negative 5. Solve each of those equations. I'm going to add 3 to both sides. That's going to cancel on either part, and then it's going to be 2x equals 8 on this side, and 2x equals negative 2 over here. Again, the steps are all the same, so I'm going to divide by 2. X equals 4, and x equals negative 1. That's pretty much it. So all you have to remember is that in order to solve an absolute value equation, you have to solve the positive and negative version of that absolute value. Then we get to inverses and composition of functions. Remember, inverses of functions is a process where you take a function and you find out what would happen if you switch the x and the y. So the way this works is the first thing you need to do is you need to replace the f of x with y, so that we can do the real first step, which is to switch the x and y. This becomes x equals 5y minus 2. Once you've switched them, remember that this process is to then get y by itself again. So we're going to add 2 to both sides. That gives me x plus 2 equals 5y. Let's bring this up here. X plus 2 equals 5y. We're going to divide both sides by 5. You divide that whole fraction by 5, and you end up with y equals x plus 2 divided by 5. And that's it. So you're looking for the answer there. And I think you might also see it written the following way. It could be written as 1/5 x plus 2/5 equals y. So just be aware it could be either of those versions. Looking at the next one, very similar process. We know this is a y. So we're going to switch x and y. We're going to get x equals 8y plus 3. And then we're going to begin solving. We'll do it by subtracting 3 from both sides. That gives me x minus 3 equals 8y. We're going to go ahead and bring that up here. And then we just continue solving. X minus 3 equals 8y. We're going to divide both sides of the equation by 8. And we end up with y equals x minus 3 over 8. It also might look like this, 1/8x minus 3 over 8 equals y. Either one of those could be the answer, depending on the way that the answer looks in the problem that you're working on. Are the following functions inverses? So now we're doing it in a test for inverses. So to do a test for inverses, you do a composition of the two, meaning you take this function and you plug it into the x value of this function. So when you do that, and you learned this in a previous lesson, but you're going to do it like this, x minus 4 over 3 minus 4. So then you start simplifying things. I see the 3's are going to cancel out, giving me x minus 4, which gives me x minus 8. Okay, once it can't be simplified anymore, you look at it. If the answer that you get is just x, it is an inverse. If not, then it is not an inverse. We went over that in the lesson, so I'll make sure you use your own notes for that. But I'm going to say here, if this was the one I was working, I would say not inverses. It has to work out exactly to x in order for it to be an inverse. Last little group of problems here. I'm actually not gonna open it there. I'm gonna go over here. Find the solutions to the system of linear equations. All you need to know here is that you need to graph these. So give me just a second to flip my computer open here. And we're going to go put these into the Desmos graphing calculator. So we have 3x plus 3y equals 15. 3x plus 3y equals 15. 2x minus y equals 7. So we see we have the blue and the red graphs, and they cross at the point 4, 1. And so that would be my solution. My solution would be the point where they cross. So again, we're looking at the intersection of the two and where they cross, and the first answer is 4, 1. Next one, just go right in. 2x minus y, or plus y, equals 4. And 3x minus 2y equals negative 1. I'll look where they cross. They cross at the point 1, 2. And so that is my answer for that. And that's all you got to know for those. So that's pretty much it. I did have this one line here, write the equations in intervals to describe piecewise functions. I will put an image to remind you of what that looks like on the answers here, but I'm not going to go over that right now. There's one of those. I think you'll remember what it looks like when you see the example on the study guide answers. And then lastly, you need to know the terms listed down here at the bottom. You need to know inverse, Gaussian elimination, piecewise function, linear equation, linear inequality, standard form, linear system, composition of inverses always equals, I'll tell you the answer right there, they always equal x. Okay? And we talked about that. Okay, so it always equals x. So make sure you have that. That was what I was talking about when we were looking at the question right over here. That's what we're talking about here. They're inverses if they equal x. All right, so that's it. Good luck. Please reach out to me if you have questions or you want to see maybe more sample questions or whatever. Just let me know what you need. And good luck on the test.